Hey everyone, this is Sam from bendingmomentdiagram.com. Today I'm just giving you a quick tutorial on how to use the Pro Calculator. It's an extra service that we've put onto our existing free calculator, and it allows you to do a lot more. More importantly, it does the indeterminate beams, which come up in a lot of exams and assignments. So it's just $5 per year, and it also gives you a whole range of other benefits that we'll go through today. If you don't already know, bendingmomentdiagram.com has a free calculator. So if you're interested in that calculator or you've never heard of it, click the link to our website and it'll take you through. Okay, so first I'll just run through the Pro Calculator and just some of the features and extra buttons. So the first thing you'll notice is there's no actual annoying ads, which is a lot cleaner to use. Now you only get access to this page when you create an account and log in, which will get set up after you purchase for a very small amount of $5. So this is what it looks like, the actual Pro calculator. Alright, so you can see it's set up in a similar way to the free calculator, except there's a few extra buttons for the extra features. With this calculator you can add a beam, 10 supports, 10 point loads, 10 moments, and 10 distributed loads. With the free calculator you can only add 3. So yeah, so obviously it's a bit more flexible with your harder questions. You can also enter a section of the beam, which is optional and is used and it's required when you're doing deflection or stress results. Alright, so let's go ahead and try and solve a beam problem using the Pro calculator and actually see how it works in action. So first thing we want to do is choose our units. So if we just go down to these drop down boxes, I'm going to go with some pretty standard SI units. So I'll select kilonewtons for force and then meters for length. So next what you want to do is add a beam. So I'm just going to pick a 10 meter beam, and you can see after I enter in 10 meters it'll draw the beam. Now for some supports. So we're going to do an indeterminate problem here, which is again only can be done on the Pro account. First thing I'm going to do is just add a pin support just at right at the beginning of the beam. So I'm going to put in 0 meters. Now I'm going to put a roller support halfway through the beam, so at 5 meters. Now at this point, if I was using a free calculator, I wouldn't be able to add another support there because that would make the beam indeterminate. But using the Pro account, I can obviously add a support at the end of the beam. Okay, so now I'm going to add some loads as well. So just a point load in the midspan of the first section, so at 2.5 meters, a downward force of 20 kilonewtons. And just to show off the calculator a little bit, I'm going to put in a trapezoidal UDL, distributed load, starting from the center support to the end support. From starting from 5 meters to 10 meters, starting at 10 kilonewtons per meter to 5 kilonewtons per meter. Okay, so as you can see, we can solve some really complex problems, a lot more lifelike problems in beam design using the Pro calculator. Okay, you can also use this table just at the bottom to edit or delete loads, which is much easier now. It's an extra feature that we've added and allows us to go back and make any changes to some mistakes we might have made. But moving forward, we're going to now add a beam section. So this is important with questions like deflection and stress. We've got a whole range of beam section types that you can add, and they're required if you're going to solve any deflection or stress questions. So in this case, we're going to just do an I-beam, which is your pretty typical beam that you can get. And again, first thing we want to do is make sure the units are right. So we'll be using millimeters, again sticking with SI units. It's just an easier way to manage beam sections. So the flange width will be 150 millimeters. Flange thickness 10 millimeters. The web height 140 bottom flange is going to be the same, 150 and 10. Then web height is 140 millimeters, web thickness 10 millimeters. Now, in order to do, again, deflection and stress, we need to enter the Young's modulus, or the modulus of elasticity. This is commonly denoted as an E, so you've probably seen this around. I'm going to pick from the common material list. I'll go with aluminum, which has a modulus of 69 billion pascals. You can also change the units there. So if we change it to gigapascals, we see it just adjusts to 69. Okay, so the other sections we can do as well are rectangular, hollow rectangular, circular, hollow circular, I-beam, T-beam, L-beam, H-beam, triangular, and we can even add a custom moment of inertias for any other types that you might receive. Again, this is a feature of the Pro, so you can't do this in the free calculator, so you'll notice on the free one that you won't have those add or edit section buttons available. Okay, so moving ahead, we're going to just add that section. And you can see just underneath the section there's a table telling you where the neutral axis is and where the moment of inertia is. Which is, yeah, again, just another way to check your answers and check you're following the problem well. Okay. So I think that's pretty much it. We've added everything we need to. We've added the supports, the beam, the loads, and the section. And we're ready to solve for deflections, bending moment diagrams, stress force diagrams, and the stress calculator as well. So, sorry, the stress results as well. So I'm going to go ahead and hit solve now. It might take a little time just to load. And straight away you can start seeing the free body diagram. So this is showing your reactions at the supports. As you can see, there's 3 reactions, obviously, for the 3 supports. And yeah, you start to get a nice clean diagram that you can use for your reports or for your assignments. It's a great way to check your answers as well. If you know, some assignments might require you to do hand calculations, like long tedious work, and you don't even know at the end whether your answer is right or wrong, but this allows you to check your answer, yeah, which makes sure you're getting the right results. Scrolling down where you have the shear force diagram, you can see, yeah, very nice, again, neat diagrams. You've even got a little box up here where you can select where along the beam you want to do. So for instance, 3 meters, we can see what the shear force is, what the shear force magnitude is at that point. We've also got, in the box just right next to it, we have the shear force equations. They're just for your reference as well, so you can see what's going on in those beams, within those beams, between the supports. So if we look at 6 meters now, there's 15.6 kilonewtons again, and we can see that in the 6 meters it would be constituting to the, referring to the V3 formula, so V3x there. Okay, so scrolling down again, we've got the bending moment diagram, which is often the most, well, one of the most important diagrams for beam design. You can move those numbers around, so you see if they do start to collide and you want to see the clear results there, you can move the numbers around. And again, we have that little text box there where you can evaluate a point at any point along the beam. Again, we have the diagram, the equations, yeah. And that's not a feature on the free calculator. You need to have the Pro calculator have the equations and to have those evaluation points along the beam. Yeah, and along with also reversing the BMD sign convention. So again, they'll all come in very handy with assignments and things like that where you need to actually prove the work that you've done. Okay, so scrolling down again, we have the vertical deflection results. Now this assumes an elastic curve. Again, not nice neat diagrams, and these can be very useful in actual beam design, just to check you're getting a reasonable result. You know, if you want to make some, say, initial calculations of a beam section, you can see, you know, roughly what the deflections are and whether you're, you know, within the required range of a standard, for instance. As you can see, using an indeterminate beam, so there's actually two deflections. The deflection is a lot heavier where the distributed load is. So yeah, for that green distributed load, the deflection's a lot greater. Again, same with the SFD or the BMD, you can select where you want to see, which is again a pretty handy feature to have. So scrolling down, we've also got underneath, we've got the table, the deflection values, where it shows the maximum deflections, which is, I guess, the most important information. It shows you where along the beams I have as well, so valuable information again. And finally, we come to the stress results. So this is it gives you stress, the results of the stress in the beam at certain points in the section, in the beam section. So we've got like the extreme stress results, which is arguably the most important because they're the ones in the furthest fibers in the beam, and it tells you, yeah, the shear and the bending stress in compression and in tension, and it also tells you whereabouts in the section it happens, the Y location there. Yeah, and you can also change your stress units as well if you need the answers in a certain unit. Okay. Again, you can select the custom stress results along the beam. So if you just enter, say, 6 meters, for instance, we get the results of what's happening at that section, at that area of the section. Some added bonuses, added benefits of the Pro Account as well is that we can save the data, so you don't have to go back and forth between questions, or you might want to come back and refer to this problem. You might have put a lot of time in setting up the problem. It might even be an assignment question that you want to come back to. So this allows you to save your data without having to re-enter all those section data, all the beam data, the supports and the loads. So you can rather just save it and come back to it later when you're ready. The save results to image file, that hasn't been actually developed yet, but that's in the making, and that will basically allow an easier way for you to embed that information into your reports. At the moment, we suggest just using screen shooting. So just if you find the diagram that you want to use, just hit print screen and then just crop the diagram out of that. That's probably the most common method used so far. So I hope that's been all very helpful to anyone who's either interested in the Pro Calculator or has just purchased the Pro Calculator. Really, there's a great deal of benefit that you get from just that $5 per year. So we definitely recommend, that if you are an engineer or you're studying engineering and especially civil engineering, this tool can come into a great use over the course of not only your second year, but the entire degree. I know personally I've used it for 3 out of the 4 years I've been an engineer, and it's come in handy time and time again to either check answers or help complete assignments. If you have any questions, please post them in the comments. Otherwise, we look forward to see you using the calculator, and good luck. Thanks.